In this lesson, we're going to look at how to separate the components of air. Now remember that air is a mixture. That means that any technique used to separate those components will be a physical technique. And so fractional distillation is a physical process. Now the components of air consist principally of nitrogen, oxygen and argon. And when we talk about the percentages of these gases, we usually refer to dry air. That's air without water vapour. And roughly the percentage of nitrogen present is 78%. Oxygen is 21%. And argon is 0.9%. So there's a small amount of argon, and the last 0.1% consists of a whole load of other minor gases. Now we also need to include water vapour, but the percentage of water vapour can change from one day to the next and from one place to another. This configuration here represents a fractional distillation plant, and the first thing we're going to say is air is pumped into the system here. And the first thing that's going to happen is that air is going to be filtered to remove dust. Okay, so we have a filter, and that removes dust from the air. This air is going to be cooled as it passes along the channel, and as it does so, water vapour in the air is going to condense. Water vapour condenses, and this is the first gas to be removed, and it's going to be removed using absorbing filters before it passes into this first refrigeration tank, and this tank is going to cool the air down to about minus 79 degrees Celsius. Now carbon dioxide freezes at minus 78 degrees Celsius. So after water vapour, the next gas that's going to be removed from the air will be carbon dioxide in its solid form, which is known as dry ice. So we're going to remove CO2 from the air and collect dry ice here. Now once it's passed through this refrigerator, then the air is then compressed and its temperature reduced down to minus 200 degrees Celsius, and at that temperature nitrogen, oxygen and argon, that's to say air, becomes liquid. The dark blue here represents liquid air, and that's going to be directed towards this fractionating column. Now unlike the fractional distillation of crude oil, where the oil is heated and then the different fractions removed, well in this case the air is at minus 200 degrees Celsius, so we're not going to heat the air, but we're just going to let it warm up. And as it does so, then the gas with the lowest boiling point, which is nitrogen, and nitrogen has a boiling point of minus 196 degrees Celsius, will evaporate first, and so the nitrogen will rise to the top of the tower and will be removed here. So we've got nitrogen coming off here, and that will be collected and stored under pressure, and that will leave at the bottom of the tower a mixture of oxygen and argon. Now the oxygen has a boiling point of minus 183 degrees Celsius, while argon has a boiling point of minus 186 degrees Celsius. So these gases will remain at the bottom of the tower in the liquid state as the nitrogen boils off, and so will be removed via this channel here in the liquid state. So we have oxygen plus a little bit of argon. Now argon is a noble gas, that means it's an inert gas, it doesn't react with anything, so the oxygen can be treated more or less as if it were a pure gas.